Today we will continue for board examination as well as competitive. Okay. 12th class. Okay, and the chapter is wave optics. Now we will continue. First we will start with the introduction. In 1637, Descartes gave model of the light derives Snell's law. It explains the laws of the reflection and refraction. I hope you are familiar with the both term reflection and refraction of light at an interface. Okay. The next one is the corpuscular model predicted that if ray of light or refraction bends toward the normal, then the speed of light would be greater in the second medium. This corpuscular model of the light was further developed. Okay. Once again we will continue. Network issue. Okay, the next one is the corpuscular model of the light was further developed by Isaac Newton in his famous book entitled Optics, and because of the tremendous popularity of this book, the corpuscular model is very often attributed to Newton. In 1678, the Dutch physicist Christian Huygens put forward the wave theory of light. It is the wave model of the light that we will discuss in this chapter. As we will see, the model could satisfactorily explain the phenomena of the reflection and refraction. However, it predicted that on refraction of the wave bends towards the normal, then the speed of light would be less in the second medium. This is the contradiction to the prediction made by the using corpuscular model of light. It was much later confirmed by the experiment, where it was shown that the speed of light in water is less than the speed of air, confirming the prediction of the wave model. Okay, Foucault carried out this experiment in 1850. The wave theory was not readily accepted primarily because of Newton's authority and also because light could travel through vacuum. Is it? Okay, on the next page we will see. Okay, it will be resume as well further because this is the connections of the net. While we will continue, it was see it was felt that the wave would be always require a medium to propagate from one point to another. However, when Thomas Young performed his famous interface experiment in 1801, it was formally established that light is indeed a wave phenomena. The wavelength of visible light was measured and found to be extremely small. For example, the wavelength of the yellow light is about 0.6 meter. Because of the smallness of the wave of visible light in comparison to the dimensions, typical mirror and lenses, is it? Light can be assumed to approximated travel in the straight line. This is the field of the geometrical optics, which we'll had discussed in the previous chapter. Indeed, the branch of the optics which one completely neglects the fitnesses of the wavelength is called geometrical optics, and array is defined as the path of the energy propagation in the limit of the wavelength tending to 0. Is it? Okay. Next one is, after the interface experiment of Young in 1801, for the next years or so, many experiments were carried out involving the interface and the diffraction of the light waves. These experiments would not be satisfactorily explained by assuming a wave model of light. Thus, around the model of the 19th century, the wave theory seemed to be very small established. The only major difficulty was the since was thought that a wave is required to medium for its propagation. Okay, how could light wave propagate through medium? This was explained when Maxwell put forward his famous electromagnetic theory of light. Maxwell had developed a set of the equations describing the laws, electricity and magnetism, and using the equations he derived, which is known as the wave equation, from which is predicted the existence of electromagnetic wave. From the wave equation, Maxwell could calculate the speed of electromagnetic wave in free space, and for focus the theoretical value was very close to the measured value of speed of light. From this he propagated the light must be what? Light must be electromagnetic wave. Is it? Thus, according to the Maxwell, light waves are associated with changing electric and magnetic field. Changing electric field produces a time and a space varying magnetic field, and the changing magnetic field produces a time and a space varying electric field. The changing electric and magnetic field result in the propagation electromagnetic wave even in vacuum. Now, in this chapter, we will first discuss the original formulation of the Huygens principles and derive the laws of the reflection and refraction. Section 10.4 and 10.5, we will discuss the phenomena of the interference, which is based on the principle of the superposition. In section 10.6, we will discuss the phenomena of the diffraction, which is based on the Huygens principles, furnace principles. And finally, the section of 10.7, we will discuss. Okay, now we can see Maxwell had predicted the existence of the electromagnetic wave around 1885. It was much later, around 1890, such Heinrich Hertz produces radio wave in the laboratory. J.C. Bose and G. Marconi made practical applications on the Hessian waves. Okay, so we will continue. The next subtopic is thank you for watching.